Hello and welcome. Happy Monday. Here we are. It's a brand new week, and we're still here. I think that's a good thing. We're kind of starting into our new work week. We decided that you know what, we're gonna go down to maybe only doing, like, I don't know, 3 to 6 shows a week instead of 9. No, seriously, we're looking at we got to get our new 3-day-a-week program going on. Obviously, we will break that rule whenever we feel fit, but we're trying to make it predictable for a few reasons. Number one, it's starting to get sunny out. People are you know, this unfortunately is probably going to go on another few days, few weeks, and we understand that people going to try and find a new work-life balance, and we want to encourage everybody to find times in your community to go volunteer, to be a part. As these shelter-in-place orders start to get lifted, you know, this is our time to be reaching out to our neighbors, to our friends, to our families, and find some opportunities to interact. I'm kind of going stir crazy. I'm ready to do a few things, but at the same time, I'm having such a great time. I mean, the topics we've been dealing with, like today is a perfect example. We've always said, we come in up here and then come down with some info, or come in down here and go up with more info. Today, really, this week of our series is all about topics that people have been saying, hey, I'd really like some more specifics around X. And so we listened. David, thanks for joining us, man. I got to say, every manufacturer has been so great to provide all their excellent resources and people to engage with the audience. And obviously, Riedel has been right out there in front from day one, and we really do appreciate that. Today, like we said, is about Luminex switches. It's about Bolero. It's everything in that switch, right, in traffic. So today is going to hopefully be as much about asking questions of David. And if you've got some really specific questions, bring them on. Let's get them out there. We'll talk at the end a little more about kind of what the rest of our week holds. But Pete, Mac, good to see you. Mac's already put in a whole day of work.
Yeah, exactly.
He's the only guy double dipping right now. He's like, I'm gonna go out work a show and then I'm gonna go work another show. But why don't you guys talk about some Q&A, because I think today could have a fair amount of that, and then we'll get going from there.
Well, we certainly hope it's going to have a fair amount of that. It's mostly familiar names I see on the list there, but we'll go over this yet one more time. In the GoToWebinar control panel, there's a little pull-down menu that says questions. If you pull that down, at the bottom, there's a box where you can type your questions in. Please be specific in your question, because when you ask it, it may be 2 minutes later, it might be 20 minutes later when it gets answered, and it will be very difficult to know what you're referring to if you're not specific in the question. The same thing with comments. If you're just responding to something that was said, please be specific and say what you're responding to, so that it makes sense. I'm looking forward to this. This is a topic that I keep slowly getting my head around, dealing with the Luminex switches and Bolero and PTP timing and all of that stuff. And I'm very much looking forward to this, because in his last session, David was a very clear presenter, got a lot of information across, and I'm looking forward to getting a lot across today. So I think, Pete, you want to kick us off here? And
me too. I'm really eager to look at. I've used Luminex switches on a dozen different shows, and been really happy with them, because I found 99% of the time, if I do a factory reset on the switch, it does everything I want it to do, and it works perfectly. So, and I didn't have to learn about it, but I did appreciate ease at setting up VPNs and that sort of stuff, and the color coding and that kind of stuff. So it definitely is a terrific little switch. Not that a lot of other switches out there aren't, but this one was particularly nice in that respect. So David, take it away.
Yeah, thank you, Peter. Thanks, Mac and company. Good to see you again. Today is going to be a pretty deep dive topic for some of you. For some others, maybe not. But what we're going to start with is really going over the Luminex switch configuration. You know, the actual practical elements of how to get into the switch, how to identify what's happening in the switch, how to make it do what we want it to do. From there, we're going to parlay things into talking about best practices, scaling networks. What are the important elements of a network? In this case, with respect to or in the context of Bolero, and you know, just the very delicate, precise nature of things like Bolero. Use cases in AES 672110-30 in this case. So let's waste no time and jump right in. Let me know if you guys see my screen. I believe you do. The first thing we're looking at.
Got the switch.
Great. The first thing we're looking at here is really just the home page of your Luminex switch. On the back of every frame, you're going to have a factory issued IP address. So easy enough to find. It's hard labeled on the back of the device. Browsing into that using any browser. I particularly like Firefox. I have found in the past that there are some little eccentricities with some of the other browsers that happen to mask some of the elements of the Luminex UI.
David, could you zoom in a little bit on that browser so we could see it? The text is too small to see what it's all about. Just a command plus a couple of times.
Yeah. Yeah, I think actually I'm probably going to have to leave it like this because other pages are going to be full page effects, if that's okay with you guys. But the good news is a lot of the text that you're seeing is not, at the moment, is not crucial information. I think the most important thing on this home page is the graphic of the switch itself. You guys can see that okay in the upper left, I assume?
Yeah,
yes.
Pretty small.
Okay. All right, great. So what we're looking at really is color codes. And the first thing you want to do when you browse in, you're going to be defaulted to this home page, the status page. And the first thing you want to do is just get familiar with your color codes. So the ports that you can see in the upper left, ports 1 through 10, you're going to see that they're blue. You're going to see that their port is green with a yellow LED on the top of the green port. Okay, so a lot of information that you can see in a short period of time. What the green is indicating versus the orange over on ports 13 and 14 is your port speed. Okay, so green is indicating a 1 gigabit connection. Your orange on ports 13 and 14 are indicating a 10 or a 100 meg connection. The yellow above the green rectangle or the yellow above the orange rectangle in the case of port 13 and 14 is simply telling you that PoE is present because this is a PoE capable switch. If that yellow LED on port 1, for example, went from yellow to orange, that would indicate that you are now sourcing PoE information as opposed to being ready and not detecting a powered device on the port. Okay. Basic stuff on the right-hand side of the switch, you're going to see 2 orange LEDs that say PSU or PoE. That's just indicating in a good dog, bad dog sense that you are sourcing power to the unit itself, and that the PoE power supply is being distributed and ready to go. No faults, no nothing. On the ports themselves and the port status lists, although it's pretty small. You can see the colors blue, you can see the colors red. You can also see an icon to the right of the red squares, which is showing what looks like a stopwatch. And what that's telling you is that PTP is being attributed to any port labeled as red. And the color coding of red and blue, in this case, of the overall port itself, is telling us what VLAN or what group that these ports are associated to or assigned to. And in this port status list, we can see the port number, the group name, and the speed of the port. As well as to the right of that, IP settings, what's the current address of the switch, what's the name of the switch. If you had switches in different locations in a larger cascaded system, it may be important to you what the name of the switch is so that you can understand what geographical location in a venue the switch is or what purpose it's serving, something like that. So moving on to the global menu, this is basic Ethernet configuration. You can change your IP address here. It is routable, so obviously, layer 3, you can find it anywhere in the network. You can change the name and the ID and the description of the switch in the ID settings window to the right of that window. The name obviously is generic, arbitrary. The ID number as well. The ID number has no technical bearing on the operation or assignment of the switch. Below that, very important window, IGMP. For this particular item, it's known as IGMP unknown flooding state. So, we'll get into talking a little bit more about what IGMP is, but I guess in general terms, let's just say that IGMP, Internet Group Management Protocol, is used for two things. It's used for having a mechanism on a network for switches and subdomains containing switches to query other switches and to report and catalog and categorize group memberships, multicast group memberships. And again, we'll talk about that a little bit later. The other purpose is IGMP snooping, which is what this particular item has to do with. In any switch such as this, where you're going to host Bolero multicast traffic, multicast traffic can be very effective. It can be a very effective way of routing and associating audio streams among edge devices, but it can also be fairly intrusive in terms of, let's say, the general health and capacity of a network. Multicast traffic can have a tendency to flood a network, to potentially create overrun situations, to be a little bit of a bandwidth hog. Now, not that that's a bad thing, but when you're an edge device on the network that, let's say, is not multicast, for instance, if you had a Riedel intercom panel that was running 2110-31 as opposed to -30, you are going to be a unicast endpoint in a world full of a majority of multicast traffic. And what that's going to do potentially is overwhelm that endpoint, having to inspect packets and be bombarded by packets that it has really nothing to do with. So what IGMP snooping does is it filters out that traffic, and it for the benefit of the unicast endpoints, prevents the multicast traffic from being routed to them. Okay. Now, this particular setting, IGMP unknown flooding state, basically says that if there is traffic, if there is multicast traffic that is not registered to a legitimate group, are you going to let it in? Are you going to route it as a switch to all endpoints? In this case, I am, simply because on my network, I have nothing but Bolero traffic. So by default, there is going to be no unregistered traffic. If you had a larger network with multiple flows from multiple types of endpoints, let's say you had -34 wire, you also had Bolero, you had other groups of traffic, for the purposes of trying to conserve a little bit of space anticipating that you're going to be in a high bandwidth situation, you might uncheck this box so as to not forward unregistered multicast traffic. That's all that really means. Okay. Port settings, which is our next submenu. Stand by. Port settings allows you simply to select a speed if you wanted to assign that port hard and fast to a particular speed as opposed to auto. Really not a lot of information here. Utilities, a few interesting things. These have more to do with not really network elements, but really the switch management elements. So there's a window called reset. The first choice, preserve IP settings to keep the device reachable at the same address. Basically, all you're doing here is you're saying, if I reboot this switch, will it come back to the same IP address that I have programmed it to, or will it come back as a default address? Also below that, a checkbox for preserving all user profiles. Again, this is a matter of what Pete alluded to, of having a switch come back in the same position, in the same state, with the same configurations that it did before the reboot, or if you go back to a kind of generic first birthday. As well, you can add security passwords here, user authentication if you choose to. The default username when you log into this switch is simply admin, lowercase ADMIN, no password. So you can add a password here if you so choose. The last box in the lower right, default profile. Basically, this is a checkbox saying that I want to protect the profile in slot 1 from being overwritten. So when we get through the switch, you're going to see at the end that there's a subheading called profiles, where you can basically store a series of about 6 or 8 configuration presets. So what we're saying here is, the configuration preset in position number 1 is going to be our default, our template, the Bible that we're going to go by. So you always want to try and protect that as a kind of a generic default profile, above and beyond the factory reset. Okay. Profile, the last subheading in this section is really just giving you an opportunity to see what version firmware, what version and revision level it's currently running. The nice thing about this switch is that you can activate alternative firmware. So if you had an issue with the current version, let's say that Luminex released a brand new firmware revision, and maybe, not saying this has ever happened in the history of the planet, but maybe somebody released a firmware version that was a little buggy, and it just came out and maybe didn't go through all the testing it needed to. If you get into the middle of set day and you loaded the firmware and it's just not acting right, you can activate the prior firmware that was running on that switch automatically by just clicking on this button, and off you go. It'll basically reload the old firmware and you're back to base 1. So a pretty effective little tool. Your next menu, RX Link. RX Link is Luminex's answer to, I would say, for lack of a better term, the switch version of 2022-7, in the sense that you can activate primary and secondary links between switches, complements of the trunk ports that connect those switches. So RX Link gives you the ability to go up to your interface and select, actively point and click over any of the ports on the graphic image of the switch, and then enable RX Link. Basically, you're only going to do it for the trunk ports, for the ISLs, what Luminex calls ISLs, or inter-switch trunk links. You're not going to do it for the local access ports, which are going to be, ports 1 through 20, or optionally 1 through 24. The reason I say optionally is because ports 21 through 24 can serve as additional LAN ports or can serve as ISL trunk links as well. And they can do that in copper form or SFP form. So a little bit more wiggle room in terms of how the switch is built to serve your needs in a high capacity show or a low capacity show where you only need a couple of trunk link ports. So just to expand on that for a second, obviously the Luminex therefore gives you the ability to, really kind of tackle more challenging topology in a venue because of the fact that ports 21 through 26 inclusively are SFP based. So they can either be copper based or fiber based. And if they're fiber based, obviously you're not stuck to the standard old fashioned 300-foot copper rule of extending data over switches. So nice to have. So what RxLink does basically is just that. It creates a secondary link between switches and it maintains RTSP, rapid spanning tree protocol. It maintains the structure, especially in a layer 2 format where you're not connecting more than one link to two common switches, thereby creating a ring and creating havoc on your network. So you only ever really want one connection between these switches. And if you have a failure, what it's going to do is work with RTSP, work with spanning tree protocol to disable the first port and enable the second port. Now in the advanced menu, once it responds, we have something that's related to using RxLink in a slightly different fashion. As part of RxLink, what they have is something called multi-links, and multi-links kind of piggybacks onto RxLinks by not only creating redundant trunk paths between switches, it also gives you the ability to aggregate higher bandwidth. It also gives you the ability to decide what path that bandwidth is going to take. And again, multi-links riding on the back of RxLinks gives you the ability to kind of up the ante. It says, listen, maybe I have more bandwidth than a 1 gig connection. So maybe I need 2 paths instead of 1. What path is it going to choose to get between point A and point B? Again, maintaining this spanning tree protocol where you're not creating, these feedback loops, it continues to work and try to figure out the best path. If it has 2 possible paths to take, it's going to take the path that has the best link cost. Okay. Auto mode, what we're seeing here is an algorithm that Luminex wrote that they feel is better than the standard path cost that you might find in any generic form in a Cisco or Arista or any other switch in this enterprise category. Most of path cost or auto multi-link cost takes into consideration how long it takes to get from point A to point B, the speed, the data rate of the connection, and the current bandwidth. So it takes all that into consideration and chooses the best path to go down. If you're dealing with throwing a Luminex into a network that also contains Cisco switches or any other, normal plain vanilla third-party enterprise switches, you're really going to want to use your generic path cost because that's what those third-party switches understand. The multi-links, which is the choice below it, is really a proprietary algorithm that Luminex uses. So if you have all Luminex switches, that's probably the better one to use. Okay, so a lot of information here, but again, not that you have to memorize it. We just want to make you aware of it. We want to show you where these menus are, so there's a little bit of recognition in the future as to what they do and what they can possibly do for you. Okay. On the group subheading here, pretty basic. And as Pete alluded to, this switch is very, very easy to configure, as you probably, concluded already. This is not your average Cisco switch where you're going in, through command line interface and, needing a degree to program the thing. This is very graphical. It's very intuitive. It's very basic. Provisioning a port to a VLAN is as easy as choosing the port by going up to the top to the graphic representation of the switch, clicking on a port and watching it change color or watching it not change color. Okay. For instance, I am on what's called the ISL group 0, which is gray. I'm choosing what ports I want to be trunk links. In this case, I have a very kind of low volume network, so I really only need one link, maybe two, if I want to get into bandwidth aggregation, if I want to get into trunk redundancy, using RX links or multi-links. But in this case, it's very basic, so I've really only provisioned 2 ports, 25 and 26, to be group 0. Okay. Now, if I just continue using my mouse to click my way around this wheel, you'll see that we have all kinds of different groups that are possible here. So, basically it's a very basic network. Like I said, we've got our 25 and 26 ports, which are our inter-switch trunk links, ISLs, as Luminex calls them. VLAN 1, which is our management port. I'm using that for anything that's out of band management. And I say out of band as in any third-party software mechanism that you're going into to configure things. Anything that's a user interface, like Director, like AZ Edit, like anything that's just a management device, not a media device. Okay, so typically I'm going to design a network where I throw all that stuff onto a separate VLAN and just let it be there. In group 2, VLAN 2, which is all my red groups, all my red ports, I've created this and named this as the media VLAN. This is where all of my 2110-30 multicast traffic is going to be. So by design, I could have thrown all of the management interfaces that are on ports 1 through 10 shown in blue on what we're calling VLAN 1. I could have thrown that all into the media VLAN and just said, okay, I'm going to enable IGMP so that all of the media network interfaces, attached to people's PCs running Director or AZ Edit or whatever, are protected from multicast traffic. I could do that, and IGMP would do that job for me. But by design, I've chosen to kind of just make it as clean as possible and separate management and put it on a separate VLAN. That way, it's physically completely separate. Also, by putting it on a separate VLAN, it also enables me to deal with it as a separate traffic group as it's passing through the ISL links from switch to switch. You're not throwing everything in one bucket. So you're giving yourself the ability to, identify, focus in on, and manipulate a specific VLAN as opposed to throwing all of your traffic in one bucket. So because all of my media is on this red group 2 that I called media, I want to go to the advanced menu and I want to look at some elements here. Here's where you're going to find the IGMP snooping and querying checkboxes. Okay. In IGMP version 2, which typically we're running either version 2 or version 3 these days. Version 3, not super necessary. What version 3 adds to version 2 is source-specific multicasting. Nothing that we're going to use in this basic layer 2 network. So IGMP version 2 is really going to hit the mark for us. And version 2, what it brings to the table over version 1 is the ability to automatically elect a querier in the network. And basically what that means is any switch that understands IGMP and can participate in it, such as this switch, is going to be able to take over as the courier. You want one switch in the network to be kind of that that news reporter or that traffic cop that's going to go out and make inquiries to all the switches around it in the network and ask those switches to report their multicast group memberships. Once that one switch that's been elected the courier gathers all that information, it uses that to help in the process of routing and forwarding the multicast traffic. Okay. Now in version 2, IGMP version 2, there is an automated process where even if every switch is capable of being the courier and every switch has this checkbox checked and is trying to be the courier, and there can be only one, version 2 has a mechanism where it chooses the device with the lowest serial number, basically. And again, snooping, like we talked about, is kind of the process of inspecting packets and routing packets to only devices that ask for it, that request it, and not in a broadcast form to flood it to unicast edge devices as well. Okay. PTP below this, PTP v2, obviously we're checking this box because we want to associate network synchronization to this switch. We want this switch to say, hey, you know, we're going to pass basically network synchronization information through you to the endpoints, and we know that you understand that language. We know that you can detect this network sync known as PTP. So we want you as a switch, you know, between your ingress and egress ports, you know, between from where the signal came to where the signal is going to, this edge device, we want you, the switches, to participate in what's called the PTP offset correction or error correction. Okay, and basically what this says is you start off just like in the video world or the audio world in the old days. You know, you have black burst, and you know, every time that this signal propagates through a device, every time it goes another 100 feet, every time it goes through you know, a record device or a storage array or through a switcher or a router, there is some effect in terms of offset of your time base. And obviously that's why, you know, we came up with things like in the old days, time-based correctors or frame syncs or reclocking DAs. And what these devices do is they kind of regenerate and reset to zero your synchronization in time base, so that the sync pulse is still at 0.0 everywhere on the network. And obviously, devices on a network hanging off the network, in this case, let's say Bolero antennas or AES-6-7 matrix cards sitting in a matrix frame that are talking to those antennas, all those devices are sitting on different ports, on different switches, on different parts of the network geographically. So all of those devices are going to be receiving that heartbeat signal, that synchronization signal, at a slightly different stage in time. And the point of this is that they all need to see that synchronization message at the same point in time. They have to make believe they're in the same place at the same time so that all the devices are synchronous. So what activating PTP on the switch does is it tells the switch to participate and correct the offset, the PTP offset, as that signal goes through the switch, because every switch's hardware is going to create an offset in time because it takes time for the signal to go through the switch. It's called resonance time from the ingress port to the egress port. So the switch basically corrects that offset and then passes the message on to the next switch. And if all the switches do this, by the time the sync message gets to the edge device, to the antenna, it's going to see 0 time.
David?
Yeah.
Before we get too far from VLANs, Daniel asks, are the VLANs assigned to a group assignable, or do they only match the group number? What if you need more than, what if you need a VLAN other than 1 to 20?
Yeah, basically the Luminex switch, the software management, the way it's designed, will only give you a finite number of groups or VLANs. You know, you can usually work within those confines because you're usually never going to effectively find a demand for more than 20 VLANs, let's say. But that is finite. You can't increase that. You can't change the
Do
numbering.
they have to be numbered 1 through 20?
They do, but those numbers are completely arbitrary. They don't really mean anything.
Okay.
And the color code is really just a default color code that says, you know, group 2 is going to be red. You know, group 5 is going to be this color, that color, etc. Yeah.
Regarding PTP, how do you use PTP for Dante and PTV V2 for AS67 simultaneously?
We're going to get to that. That's going to be the main course.
Okay.
And that's a great topic, and that's really the first challenging one I ran into when I was designing these networks, is because everybody wanted to put Dante and AS67 or -30, -31 onto a common network infrastructure for obvious reasons. I mean, you know, this network hardware is not cheap. So, you know, that's the first thing a client's going to do is say, can I throw this all onto the same network? Please say yes, please say yes.
Is PTP mode the selection of transparent or boundary type clock?
Yeah, so
Or the mode setting?
Yeah, so what we're looking at here is two choices under PTP, E to E and P2P. E to E is end-to-end. P2P is peer-to-peer. And you might think to yourself, well, peer-to-peer, that's a boundary switch mechanism. Why, if this Luminex switch and all Luminex switches are transparent capable and not boundary capable, what's that selection doing in here? That selection is here because it needs to know what the neighboring switches are. You know, if the neighboring switches are more transparent switches, then you want to run in E to E mode.
Right.
If the neighboring switches are boundary egress or boundary ingress, depending on which side you're going to and from of the transparent switch, you're going to be in P2P mode. Now, currently, yeah, go ahead.
Stan wanted to know if using multiple switches, do you need only one PTP V2 check on one switch, or do they both have to be on?
Basically, you want to enable PTP on every switch in the network that's capable of it. You know, and that's a little bit of a longer answer because, you know, the more switches that are PTP capable, the more accurate the synchronization is. And the more accurate the synchronization is, the healthier the network, the more accurate is the delivery of packets, the more accurate is the synchronization that the Bolero system and the DECT FTDMA system is sampling from network PTP. And the more accurate that DECT timing is, the more accurate your belt pack audio is going to be, and the more accurate the playout of the codec is going to be, because the codec references to the DECT timing. The DECT timing references to the PTP timing on the network. The PTP timing on the network references back to the Grandmaster, which is the you know, the Grand Poobah device that's generating the PTP on the network.
Caleb asks back to the number of the VLAN number. When you're using Luminex with other switches, you can change the VLAN number that the group corresponds to in the vid line and make it anything you want.
Yeah. Yeah, you can.
Yeah. And
now,
along
you know,
the same line, Dave says the same thing. The vid field in the group advanced settings, you need to match other VLANs in an existing network if you're plugging this in a network that already exists.
Yeah, this number is what they're referring to. But, you know, again, this isn't going to directly affect what you're naming group 2. This is a reference value for the group. from group to group coming through your trunks.
Would that be the same number, the VLAN number on all the switches? No.
I mean, if you're running 5 Luminex switches and group 2 is your media, as a best practice, I would always match those numbers in the vid category.
I think what he was referring to is if you come into a situation where there's an existing network that has a bunch of VLANs in it and you want to access those VLANs that may be numbered totally different than 1 through 20. You can renumber the vid number.
Yes.
Irrelevant of the 1 through 20 colors.
Yeah, correct.
Okay.
Correct.
And Zachary wants to know, does the group number correlate directly to VLAN ID? And I think we just answered that. No, it doesn't.
Yeah, correct. One more important thing on the grand scheme, just important that everybody understands the idea. I think they do, but end-to-end, in this case, EDE, is a mechanism that you want to use if you strictly are implementing transparent switches, which all of these Luminex are. If you're not mixing and matching boundary capable switches on either side of it. It's important to know that the mechanism in PTP that helps measure offset correction between edge devices and the master is something called delay request response mechanism that's part of PTP. That is an integral part of the end-to-end mechanism, because what's happening is end-to-end through the network, these switches are transparent, meaning they're, in terms of offset correction, they're transparent. What they do is they provide offset correction data to travel onto the next switch segment and onto the next switch segment until it gets to the edge device. The edge device then takes that information and uses it to calculate its PTP offset in the network so that it can appear to all the other devices as being at time 0. So that is truly an end-to-end process. The switches contribute, but they don't correct the value as a boundary clock does. You know, a boundary clock is more like a frame sync where you have an ingress port, it references to slave ports, it reclocks, and off you go at the egress port at time base 0 again. So a much different animal. And in that sense, if you're using transparents and you're using devices that understand this mechanism of delay request response, you need to be using the EDE mode and not the PTP mode.
So question from me, the colored 1 through dial-up switch numbers have no relation to anything in the outside world.
Correct.
Other than other Luminex switches.
Yeah, they're really there.
Each one can be assigned to a different VLAN that may exist as set by the vid number for each one.
Mm-hmm. Yeah,
okay.
So they're really for, you know, the color coding is really just for quick identification of, you know, who's on what in a generic sense.
Got it.
As you do your housekeeping, looking at your switch config. But it is important to look at the bigger picture. Yeah, as mentioned previously, you know, you might be going into a network that's already predetermined in some way somewhere else. Another important mechanism that you're going to see in this menu is domain below the mode, the PTP mode. Domain is really a tag that's given to all the data in a particular VLAN to categorize that traffic. And that's referenced to the domain ID value given to the edge devices that are on that VLAN that are looking for this particular traffic. And that's also tracked back to the grandmaster, the PTP generator is going to be generating a domain ID value. So what we're doing is we're creating a mechanism where we're giving the network a mechanism to track and identify common goals, let's say. You know, any device with domain ID 0 is going to be on the media VLAN, and we're going to assign a domain ID value of 0 to the grandmaster PTP generator. So you're referencing all of these things to make sure that the devices that need this PTP are receiving it, compliments of this tag saying, hey, I'm part of that kind of domain 0, I need that stuff, just so you know. And basically it's a ways and means for edge devices to open and inspect packets and identify the appropriate domain ID that's been configured to them, and then see that value coming to them from the network and realize that that packet is for them and I should keep it as opposed to throw it away. So another important mechanism to help categorize traffic, to help affect the shaping and the flow of the network. One important thing to point out, some grandmasters, such as I think the Tektronix SPG8000, I believe has multiple output ports where you can configure multiple domain IDs. Don't hold me to that, but I think that's the case. It's one of the more sophisticated units. Although that's the case, if you have traffic on multiple VLANs, media traffic on multiple VLANs, important to know that the Luminex, you can only attribute PTP actively to one VLAN. You can't attribute PTP, and nor do you want to attribute PTP to multiple VLANs. You really want to say, okay, this is my media VLAN number 2 as we know it. I want to attribute PTP here. You don't want to attribute PTP to your blue VLAN, VLAN number 1 as we know it here, because that's just management traffic. And the switch isn't built that way where it can attribute to multiple VLANs. It's not that intelligent. You need to basically pick one. And as such, it doesn't really matter if you want to have the grandmaster generate multiple outputs with the same exact domain ID and associate them to multiple VLANs. Because of the fact that they're segregated by VLAN, if you have domain ID 0 going to VLAN number 1 and domain ID 5 going to VLAN 2, that's fine. If you want to have domain 0 going to VLAN 1 and domain 0 going to VLAN 2, that's also fine, because there's not going to be a conflict because the data is being segregated by VLAN. So they're never going to know that VLAN 1 and VLAN 2 are going to be riding domain 0 at the same time. There will never be a conflict, in other words, in that sense. Okay, on to PoE. One thing to note off the bat here is that PoE versus PoE plus, PoE, we're really talking about a cap of 15 watts per port. PoE plus, that goes up to 30. Why is that important? For us, for Bolero specifically, upon antenna boot up, that initial boot up process in transient fashion may demand 16 and a half watts in transient upon boot up, which is over the 15 allowed by PoE. Not saying switches can't over provision power. They certainly can at certain settings. But if you imagine you have an entire network full of Bolero antennas and they're all booting at the same time and they all go over 15 watts, you don't want to be on a switch that supplies PoE, because you're just going to get into a really nasty saturation problem where, some antennas are simply just going to boot off because they don't have the appropriate power being supplied. So you always want to be on a PoE plus rated switch. Nominal operation of a Bolero antenna, you're talking about well below 15 watts. So under normal operation, it's fine. Under boot, no. So that's the difference. Also, for this switch and many PoE capable switches, it's not uncommon for the switches to not be able to supply 15 watts or 30 watts per port times each one of its ports. So if I'm trying to supply, in this case, 24 ports with 30 watts, you're going to notice that the overall value of the switch does not equate to that. It's not 30 times 24. It's far less than that. That's the basic assumption of the manufacturer saying there's no way that they're going to put 24 Bolero antennas on this switch and they're all going to need 30 watts. That's kind of the reasoning behind why they spec the switch the way they do. Okay. In a graphical sense, on the far right, you're going to see this kind of bar graph meter here that shows what is currently being used, what is in reserve, and what the total power available is. Right now, I'm using about 7 watts. In reserve is 15 based on class selection, and I have a cap of 370 watts. If I go into settings, this is going to make a little more sense. You can enable per port by selecting a port, by clicking and highlighting it, and you'll notice that it becomes embossed, the same as in the groups menu when you're assigning a port to a group. You're clicking, making sure that the port is embossed, and then you're doing something with it. Down here, we would be enabling or disabling PoE in this case. Below that, you're going to see the ability to prioritize a port. And you can give it a mission critical or a high priority or a low priority. And what this is doing, as you can imagine, is creating a scenario where if the switch is faced with making a choice and it only has so much power to give before it falls into saturation, you need to have a way to let the switch select lower priority ports to be shut off so that it can reallocate power to more critical ports if it needs to, if you get towards that cap of 370 watts. When that's important is a few cases. You can change your management of PoE in this menu, in the advanced menu. You can talk about class, or you can talk about LLDP, which is Link Layer Discovery Protocol. Before we talk about that, it's important to look at the power budgeting categories, consumption versus reserved. Okay, reserved basically says that I'm going to block off 30 watts for this port now and forevermore. No matter if it uses 12, no matter if it uses 17, I'm going to reserve 30. End of story. So there's no argument about it. If you choose consumption instead, what you're saying is, I want the switch to dynamically detect how much power that edge device is using moment to moment. And with the rest of it, let's say it's only using 16 watts, it's going to tell the switch that it can take the other 14 watts that would normally have been reserved for that port and use it somewhere else, dynamically reassign that power to somewhere else. So that's the idea of consumption mode versus reserve mode. Now, when devices boot up that require power, you're going to tell the switch to detect that edge device based on 2 categories. You can detect that device by class and simply by class. And again, when you're doing that, you're kind of combining that with the idea of a power budget in reserved mode. You're saying this device falls under this category, and by definition of this category or this class, it should get X amount of watts. So it's very directly associated to the power budget category of reserved. LLDP, or Link Layer Discovery Protocol, says once that device boots fully, it's going to have the opportunity to send a message back to the switch. And what you're saying here is, do I want the switch to detect and read out that message or not? And what is that message? The message is, I am device so-and-so, and although my class says I should be using 30 watts, in reality, I'm really only using 16. So LLDP kind of goes hand in hand with consumption mode, because then the switch says, okay, I just got a message from this device. He's not using all that power. So if I were in consumption mode, I could reuse it for somebody else. Totally fine. Now, the danger is if you have a lot of devices on this switch that are power capable devices, you could get into a situation if you're not in class mode and you're not in reserve mode, if you're in this dynamic mode of consumption and LLDP of the edge device reporting where it's really actually using moment to moment, you can get into a situation of overrun where, you know, dynamically you might exceed or potentially exceed the ability of the switch. That's when it's going to go and look at your priority settings and say, all right, in dynamic mode, I'm having this ridiculous number of swings moment to moment where I'm using a ton of power on ports 22, 23, and 24. And at other moments, I'm using almost none. But the moments I'm using that ton of power, I'm in danger of overrunning. So for brief moments, I'm going to have to shut other ports off. So it's going to go to the bucket and look for the low priority ports and try to shut them off. So obviously, I guess the moral of the story is try to stay in class management and reserve power budgets so that you're not chancing these wild swings in power and not chancing ports getting shut off. Okay, and last but not least, profiles. This is where you can store everything that we've talked about so far today. You know, store it as a configuration preset. Right now, I've got one built that's, you know, emulates what we've talked about, the settings that I've set, and I'm calling it AES67 default. And you can fill up, obviously, these other slots with other configurations as well and call them up, recall them as you need. And down here, of course, recall is basically choosing one of these defaults that's locally saved on the switch. Import, alternative to that, is you're loading a config that was saved on your PC that somebody sent you. And then export, obviously, is saving it out. The save button, as opposed to export, is saving it inside. So depending if you're going to keep everything on your switch or off your switch. So that's about it, soup to nuts, for the Luminex switch. As far as the configuration goes, obviously we'll get into some more design concepts after this, but so far, any questions on the switch itself?
So there were a couple. When tying into outside networks, Dan wants to know, can these switches act as gateways?
It depends. I mean, in the true sense of the word, no, because Luminex are all layer 2, so there is no gateway in the traditional sense of the word in terms of layer 3 routing.
If you change the vid on a group in one of the 5 switches, you have to change them on the other 4 also, right?
Well, it depends on what you're matching to other switches. I mean, if you want to have them directly associated to other switches, then you have to be consistent across the board. If
So
you're just talking about
your green is 200, it has to be 200 on all of your greens. So
I do that as best practice. Yeah. I mean,
yeah, okay.
Yeah.
What happens if you don't do that? They don't recognize each other?
That's usually the case, that you get into a situation where, you know, data is filtering through the ISLs, and, you know, one switch has one set of rules identifying the traffic. Another switch has another set of rules identifying the traffic. You're trying to combine those, and there's a discrepancy.
So basically, the VLAN wouldn't work.
That's correct. You really want to make everything consistent across the board. If you're dealing with different switches that are disparate in some way or another, you know, especially in the case where you're joining a network that's pre-existing.
Okay. And we'll probably get to this later, but do you recommend an external PTP clock for Bolero system, or just use one of the transceivers?
Yeah, and you know, we might as well talk about that now.
Well, let me ask 2 other questions before we get onto Bolero. Is there a CLI and terminal management port?
You can get into a CLI in this switch. I don't typically do it because everything that you need is really in this UI. The
Right.
only thing that's not in this UI that you would go through CLI to get to is if you wanted to change the default QoS. And because this switch has been tailored towards AES67 traffic, the DSCP tags for QoS are those that are defined by AES67. 46 for clock, 34 for media, 0 for best effort.
And how does the device deal with AVB traffic?
AVB is its own animal. It runs on its own parameters in 802.1 that have nothing to do with AES67.
Right.
So you really, it's an either or scenario, truly.
Okay, Bolero.
So in terms of the PTP master, there is a process that we'll look at in a bit that's has to do with selecting the PTP master. Most edge devices, most hardware edge devices that are capable of being masters, it will be apparent that they're capable of that, as opposed to being slave only, what they call slave only. In other words, not capable of generating, but simply detecting somebody else's clock in slave mode. The manufacturers, they manufacture these devices to varying levels of accuracy, depending on investment, depending on the probability of a device being a master or not being a master. For instance, probably the highest quality clocks that we make are in our Bolero antennas at the moment, outside of 1024, which is our new platform. Bolero antennas have the most accurate clock out of all of our hardware devices that are capable of AES67 because of the fact that, again, synchronizing a unicast key panel requires a high level of accuracy of PTP and synchronization, but not as high as Bolero because of the fact that, like we talked about before, beyond the copper network timing, once that sync message gets to the antenna has to transpose that into the DEC domain and continue to use that sync message to synchronize across RF to the belt pack, and synchronize the FTDMA, data transfer process. And that requires much more precise action than locking a unicast panel on a copper network. So that's kind of why the best clock ended up on the antenna. Now, as far as whether to use that antenna as the grandmaster or whether to use that antenna as a slave and say, you know what, this really calls for an external grandmaster. The reasoning behind that decision is really going to be based off of how many slave devices you have on the network that you're trying to synchronize, because that can be a limitation for any piece of hardware, any piece of software that's programmed into that hardware. That device is only going to be intelligent to a finite measure. If you have a Tektronix Grandmaster that costs $10,000 versus a Bolero antenna that costs $3,000, obviously the Tektronix Grandmaster is going to be more capable, most likely, because of that investment cost. And really what the antenna is doing is saying, I can be a master, but only to a certain point. I'm intelligent, but I can only keep track of, really 30 to 36 slave devices at the same time, which is, one of the responsibilities of a grandmaster is keeping track of all those devices, because the grandmaster is not only broadcasting out announce messages and sync messages, but it's also receiving delay request messages from all of the slave devices. So it can only process so much from so many endpoints at the same time. So that cap, performance-wise for us as a safe number, although we've, exceeded this in testing pretty substantially, but the safe number is 32 to 36 slave devices. If you have more than that in your network, you really want to look at an external grandmaster. And those devices are capable, not only of generating multiple outputs and generating multiple domain IDs, but they're also capable of servicing, up to hundreds of slaves as opposed to 30, 32, 36.
Why is there a limit on the number of slaves?
Well, again, it comes down to the processing capacity of the grandmaster and how many devices that it can process at the same moment in terms of, delay request messages from each other slave edge device simultaneously.
So they're communicating back and forth to make to work is the issue.
Yeah, exactly. And the higher the number goes, not that it can't do it. If you had 40, it could do it, but you're going to see diminishing returns. The higher you go and you push the limits of that Bolero antenna to look at 45 or 50 slave devices, you're going to see a lot more packet loss. You're going to see a lot more drop packets.
Can you split that between two different?
No, you really have to. Yeah, you have to pick one grandmaster and stick with it because, it's a process to get all of the slave devices married to it and operating and detecting that master. So it really can only be one, unfortunately. But, and one other thing to point out, let's remember that Bolero belt packs are not edge devices. They're not slaves in that equation. The slaves are really, you're looking at the network. You're looking at network edge devices tied to a copper network, i.e. AES 67108 matrix cards sitting in a matrix frame. Bolero antennas, those are the devices that are hardwired to that network. Those are the slave devices, not the antennas, obviously. I mean, not the belt packs, obviously.
So do you have a particular, you mentioned Tektronix, do you have a particular more powerful master you would recommend as Riedel?
Would
the 1024 be more powerful?
The 1024 is more powerful just because of its design. Every UIC is meant to host up to 128 entities per UIC. So the hardware, the accuracy of that clock has to be able to host 128 as opposed to 32, 36 in the Bolero world. So yeah, the clock quality is higher and the general capability, processing capability of that mechanism to manage 128 entities is much greater than that of the Bolero antenna.
Henry Cohen asked if the switches are stacked, so the interconnecting two switches in order to gain physical port counts, doesn't that constitute a switch hop?
It doesn't. A lot of people think it doesn't. And, it depends on what context you have that debate because those switches are linked together on logical layers. So in management, the argument is they are one switch. But in terms of mechanics and residence time inside the hardware, it is more delay. Yeah.
But less than actually separating the two switches and linking between them normally.
Yep.
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 And is there any perceived improvement in audio quality with an external clock?
Yeah, I mean, again, if you're taxing your grandmaster, let's say it was a Bolero, and you were trying to push the limits and have 45 or 50 edge devices on there, and you knew that textbook it could really only handle 36 in an optimal fashion, what you're going to do is you're going to start to have offset variances that are going to result in things not synchronizing. When things don't synchronize, then your media gets to the codec on the edge device. The codec is referenced to the PTP sync on the network. If the codec isn't synchronized quite as tightly as it should be because the grandmaster can't exactly dedicate the resources it needs to that edge device, then your codec's not going to track out correctly, and you're going to have audio dropouts, things like that.
That would be analogous to jitter.
Yes and no. I mean, jitter is a subcategory of it's a result of network traffic. PTP and the accuracy of PTP in the context of this example really comes down to the performance of the hardware and its ability to simultaneously process and host and provide offset correction messages to all of those slaves. And so that's really a performance issue of the hardware of the Grandmaster. When you get into jitter, you're really talking about the context of traffic on a network and the flow and shaping and the unpredictability of combining the traffic from one switch with the traffic from 2 or 3 other switches going to ultimately a 4th or 5th switch.
So PTP doesn't really have a jitter buffer, so to speak. You can't increase it to make your timing more consistent across the network.
Exactly. It's, I liken it to the old-fashioned example of timing a CCU to a switcher input. The switcher input has a certain variance left to right. It has a window of acceptability where it will accept that signal and cut between or fade between that signal and another camera signal and not jump all over the place because they're locked. They're both locked.
Right.
So it's the same thing. It's really the classic definition is PTP offset variance. So you're really trying to say that the clocking signal has to be within this window for all devices.
Now, would a boundary capable switch in the network reduce the load on the PTP master?
I mean, the load on the master is kind of black and white. It's either going to be capable of hosting that many devices or not. And if it's a grandmaster, an external, it's going to be capable of hosting hundreds. And the quality of the clock is going to be that much greater.
Where would you look up the load on the master? Is there any way to look it up so you can see that you're getting close?
Yeah, I mean, on the network, you can see, in Director software, reading out a log on a Bolero antenna, you can find how many slave devices are on the network.
Smart panels don't count as PTP necessary devices, right?
Oh, they absolutely do.
So if you have 100 panels on your system and 30 Bolero antennas, you're screwed.
Yeah, but here's what you can do. When you start to get to that point, you can start to think about ideas like, let's start to categorize apples and oranges. Let's start to make the network perform better. It's the old adage, just because you can put everything in the same bucket on the same VLAN doesn't mean that you should. IGMP mechanisms can route and protect unicast to multicast. It can help, implementing QoS can certainly help shape the flow in the network.
So it's really just a matter of putting your smart panels on a different VLAN than the antennas.
Exactly. So at that point, apples with apples, oranges with oranges. And once you do, 2 things happen. So remember that the Luminex switches, let's, to stay in context, let's say we're using a network full of Luminex switches, layer 2, PTP capable. You have Bolero traffic and you have panel traffic. Now, again, like we talked about, the panel traffic is unicast, so it's a much more basic process. It creates much less noise in the network, and it doesn't require quite the accuracy of PTP that Bolero does because of, the mechanisms of Bolero being decked in FTD-MIC. So what you're doing is you're saying, okay, now I remember what you said was that Luminex can only attribute PTP to one VLAN, not multiple. So now you have to pick. So if you're going to pick, if you're the switches, what traffic are you going to be more likely to help because it's more susceptible, because it requires a higher level of accuracy? You are going to attribute PTP to the VLAN hosting the Bolero traffic. So that's all well and good. Again, all you're doing is you're telling the switches to assist in the offset correction, to actively assist in the offset correction, so that the edge devices, the Bolero antennas, don't have to do that calculation by themselves across the entire network without the aid of the switches, without the switches, giving the Bolero antennas the answer to the test, essentially.
So will the smart panels noticeably work not as well if they don't have a PTP master on their VLAN?
Well, see, that's the great thing, is they're on a different VLAN. So as, let's say in the basic example, on the Bolero VLAN, you have the Bolero antenna, one of the Bolero antennas, working as the grandmaster for that VLAN, okay? That clock never leaves that VLAN. Likewise, on the VLAN that the panels are on, you can have a AS67 matrix card be the grandmaster for the panel VLAN. As long as every VLAN has its master, again, you could take an external grandmaster and attribute separate outputs to multiple VLANs so that they all have a master. In this case, if you have disparate masters, on the Bolero VLAN, one's a Bolero antenna, on the panel VLAN, it's a matrix card. It doesn't matter that they're disparate masters because that traffic's never going to, it's never going to converge,
There's no necessity to them to be synced.
Yeah, you don't need to sync panels to Bolero bell packs. They're all doing their own thing. They're never going to converge, so you're never going to see that discrepancy in masters.
So this is actually a best practice to put your smart panels on a different VLAN than your Bolero antennas.
Absolutely. For no other reason than, just because IGMP will, help with the flooding issue and help with the unicast interfaces not being overwhelmed, it's just better practice to avoid the edge devices having to do that extra work, because every time you get bombarded as an edge device, you're having to open and inspect packets. And if you're doing that constantly and none of the packets are for you, you're not going to be running really well because a lot of your resources are being, squandered away on unnecessary workflow. So if you segregate them, your traffic is going to be much cleaner and much more predictable, because on that VLAN, it's all unicast traffic. So it's very deterministic. There are not a lot of wildcards when it comes to jitter. When that packet leaves that switch, you can pretty much predict it's going to get to the panel when it should and in plenty of time. And that's really the magic of best practices on a network, is you want to try and mitigate everything within your control. What's going to be deterministic? What's going to be the most predictable things in a network? They're going to be the network stack, the internal stacking process of the switch that's about to send the message. That's very predictable. You're going to look at things like in an SDP file of a stream, you're going to look at things like packet time. That's going to be very predictable. You know, you're going to say every X amount of time, I'm going to send this much information, and it's going to have overhead associated with it because it's a unique message. So, you know, things like that, you know, the CPU of a switch, the buffering of a switch, the stacking of a switch, all of that is very deterministic, very predictable. What's not predictable is once that data leaves that egress port and it's out on the network, it's, you know, it's anybody's guess when that data is going to get to the next switch's ingress port. You know, it's not anybody's guess, that's an embellishment, but you get the point. It's out on the network, and now it's up to, you know, it's up to the switches as a group and trying to groom the flow and the shaping so that it's as predictable as it can be. And one way to do that, one way to guarantee that, again, is to implement QoS on all of the switches. Prioritize your traffic. You know, implement QoS so that it's tagging packets as, you know, as clocking data, which is the most critical, the most important. So it's going to give it the highest clearance level on the network, so to speak. Then below that is going to be your media.
Where did you set the TOS?
So the QoS is.
I thought you said TOS.
Oh no, yeah. So that's predetermined in Luminex because again, it's a switch that's tailored to carrying this type of traffic.
Okay.
It's preset with those figures in there. But it's important to implement it because, you know, a lot of people will say, well, I don't need QoS because I have plenty of bandwidth. I can just over provision the network and the trunks and I have all the room I need. It's not about how much room you have. It's all about the order of events and the timely order of events. It's all about getting the clock data there first, you know, to synchronize the edge devices, to stand up the stream so that the audio can pass through and hit the codec and play out. If that traffic doesn't get there in the right order or have enough time in between when PTP gets there before media traffic gets there, then, you know, it's gonna be an issue. You're going to encounter a lot of jitter. You're going to encounter a lot of unpredictable behavior on the network.
Now, PTP settings. Is it right that the higher the number, the lower the priority, or I have it backwards?
The lower the PTP priority, then the better chance that device has of being considered to be a master.
Okay. So typically, what would you set the AES 67 cards, most of the antennas, and the master antenna at?
Yeah, I would probably set the cards to slave only, or if I wanted them to play in the sandbox of possibly being elected, I would set them all to 126.
Right.
Then I would set my Bolero antennas to maybe 124, and then if I really truly knew that there was an antenna on the network that wasn't really hosting a lot of belt pack traffic, and it was in a strategically favorable place in the network, which is really the most important thing, because you want to create
like right at the frame where I'm sitting, where backstage would be a good thing.
Yeah, somewhere where you have control over it, where you can protect it, where people aren't going to walk up and unplug it, that type of thing. But again, it's important to have it be strategically located in the network. You want it to be in the center so that, you know, its path to any edge device is fairly balanced, you know, across the board, so that it wasn't sitting out on the edge of the network on the last switch, and it had to go, you know, a tremendous distance to get to most of the edge devices to clock them. Not a situation you want. But regardless of that, you know, again, you can deliberately give one antenna the lowest value, let's say 120 or 122, and by way of doing that, you're telling the algorithm that chooses the master dynamically on the network, which is called BMC, Best Master Clock Algorithm. You're telling that algorithm, hey, I'm forcing you because I know the decisions you make and the order you make those decisions. By giving you this value of this antenna, I'm basically forcing you to make the decision to make that one the master. Now, if you don't do that and you leave them all at the same value, let's say you leave all the antennas at 124, then the algorithm is going to go through the network and it's going to go through a battery of testing, looking at deliberate values. And if they're all the same, it's going to move on to the next step. It's going to look at clock quality, clock class. It's going to implement a practical test of that clock, and it's going to measure its stability and its accuracy. And a lot of that is going to be dependent on where it is in the network based on how it performs and what those results are.
If you let it do that, and that antenna goes offline, does the whole antenna system do a little hiccup?
It does, but it will recalculate, and that algorithm will choose the next best master automatically.
But for a few seconds, all the bell packs go offline and come back on.
They may or they may not. I've seen situations where, I was running without a master for, more than a couple seconds, and I still had connection.
Right. So so you're saying if I pick 126 for my cards, 124 for my antennas, and 120 for my safest master, those are good numbers to start with.
Yeah. And then, once you lose that deliberately programmed master, then the algorithm is going to kick in because it's time to select the next master, and it's going to see that they're all the same value and then go through the next layer of testing.
What if one of the antennas was at a slightly higher, near the master, but not near the antenna's amount? So it's sort of gradated.
Elaborate.
Well, let's say the cards are 126, the antennas are 124. My master is 120, but I have another antenna I make 122.
Yeah, that's fine, because really all that's going to happen is the next time that top master or the first chosen master fails, the BMC algorithm is going to go through that same process over again. And I think that, the matter of deliberately setting a unique number to that next antenna is secondary, because, you may decide that you think that secondary antenna is truly the next best one. But if you just set them to all the same values and let the algorithm actually test them to see in the context of this network and how it's performing what the best antenna is, you're going to be better off.
And in the GUI, it tells you which one is the master antenna.
Yeah.
Has a star next to it or something, right?
Yeah, there's actually, in the Bolero system, there's two masters. There's a PTP master and a DEC master. The difference is that the PTP master is the antenna that's in charge of generating and tracking sync through the copper network. The DEC master is the antenna that's responsible for sampling that copper network sync message and translating it into the RF world. And in most cases, that's the same antenna, because it doesn't need to be a different antenna. You could make it a different antenna if you wanted to. There's no conflict there, because one's dealing with it sync in the RF domain and one's dealing with it in the copper network domain.
Now, back in the smart panel world, is there any necessity of setting one of the AS67 cards that handles them at a different setting than the other AS67 cards that might be for smart panels?
No, again, the algorithm is going to do its job. The only time I would ever set one card lower than the other is if I truly knew that, for some crazy reason, I knew that there was one card in that frame that was better or higher performance than all the others.
Right.
Which to some level is, why assume that? It's more an issue of environment, really, where you're out on a gig, and we've all been there, and there's kind of a volatile situation in terms of the security of the hardware, or you just don't know, somebody gets a case of happy fingers or kicks a plug out. That's when you really want to think about deliberately setting a value for a master is in an environment where you know that this device is protected and it's not going to get messed with.
So you don't really think there's any real advantage between setting them all at their default values or picking a master?
No, other than to differentiate between the cards and the Bolero antennas. So if you're on a VLAN,
Yeah,
it's
yeah,
just
120, 124 on the cards, and
yeah.
Right.
But if you happen to put everything onto the same VLAN just because you don't really have that many panels or that many belt packs or antennas, then yeah, I would just put all the cards in slave only mode and not even chance any of the cards potentially taking over, because you know that the quality of the clock is better in the antennas in general.
right, right.
But again, for the panels, it doesn't matter because the panels are not as precise of a animal as the Bolero system is. So it's okay for the cards to host the key panels.
On this switch, is there any way to monitor your network traffic?
On the switch itself, yeah, I mean, you could go on and use any third-party mechanism to look at your traffic and really drill down complements of whatever that third-party software has available to it.
But nothing built into that switch per se.
Nothing built into the switch. Yeah. There is a glueware that Luminex made called Luminet that will give you some basic, let's call it systems health check and status of network traffic and volume, payload. That is a viable add-on piece of glueware. And again, when this session is over, I can certainly upload some documents for Luminet as a software UI that kind of piggybacks onto what we're looking at now, which is the web UI for the switch.
If you have multiple VLANs, I can't think of any personally, is there any need to actually interconnect those VLANs? And if there is, how would you do it without destroying the VLAN?
Yeah, I don't think so, other than, it really depends, not so much on these switches because they don't present the opportunity for you to, but in a more sophisticated switch like a Nexus 9K in the Cisco world or an Arista 7000 series, where you have the ability to get very, very specific when you're defining your trunks and the rules associated to the trunks and deciding what traffic gets mixed in what trunk, what traffic doesn't. That's where that might come into play. But in the Luminex world, it's very basic. Yes, no, good dog, bad dog. If you're on this VLAN and this switch, you're going to be on the same VLAN in the next switch.
Does this switch have any port copy functionality or port mirroring for diagnostic purposes?
Not that I know of, but I would be very confident in saying that you could get support mirroring in the CLI of this switch. It would just have to be a phone call to Luminex to get the specific command string.
Okay, yeah. That's pretty much all the questions we caught up to here.
Okay, great. So really quick, I'm going to go through some basics, and then we can talk about the Dante formula. So cables, let's all remember that sometimes it's the basics. Sometimes when you get into situations where you have a lot of aliasing or you have a low performance of your system, that you could associate logically with packets being dropped, things like that. Sometimes it comes down to the basics, equalization of a cable. Just because a cable says it's Cat6, you really want to make sure that you look through that sweep and you make sure that your attenuation per unit distance is within the specifications for Cat6 and for AES 6.7, you know, all the way up to a gig. So as you're looking through this sweep, make sure that these values are below these numbers for each of these frequency steps and not above them. Proflex is a notorious example, and I know there's a lot of it out there, so that's why I kind of bring this example up. Basic, you know, first things first to check, look at your cable, make sure you're using the right cable before you load your trucks and head off to your gig. You know, and again, you're going to see telltale signs. So these mean something. They're not random, in other words.
Back in the previous slide there, how would you test those speeds of the cables? What would you use?
So that's a good question, Peter. There are test devices that will sweep cables. I don't own one, but I know they exist. A typical handheld network analyzer that is used to proof a network in a basic sense will have that capability. You can enter preset programs to test the cable, to look at its equalization. It's basically creating data, sending it out, pinging it, sampling it back, and looking at what its attenuation is per rate, per speed, per step. So those devices are out there. They're pretty common. I just don't own one myself.
Yeah, I have a Fluke that basically tells me if my cable is good for megabit or gigabit, but it really doesn't give me a number in between there.
Yeah, and that's one of those, the more sophisticated, higher price the meter is, the more you're going to be able to dig into the granularity of that test. Yeah, but they do exist. So again, we talked about the IGMP snooping, the verification. This is just showing you what the process is for querying. That one switch that gets elected as the querier with the low serial number goes out and collects membership reports from all the other switches in the network. This helps to gather and aggregate all of the multicast groups and memberships across the board, so that when edge devices are requesting streams, there's a catalog to reference to know what group it's looking for, what the origination of that group is, between, for example, an AES 6.7 card sitting in a matrix and a Bolero antenna sitting on the far edge in a belt pack, and requesting that information. QoS, again, I can't stress it enough. A lot of people will say, well, you don't need QoS and IGMP in a layer 2 network. It's flat, it's small, it's predictable. But one of the key things is layer 2 networks are not really good at dealing with multicast traffic. It tends to flood across the board. So IGMP is actually very useful on layer 2. QoS as well, and again, the argument is I can just over provision it. Well, you can over provision it, but it's not going to stop the unpredictability of the traffic. And you can see, even on an over provisioned network, it is a great help to have QoS as opposed to not having it. And this is typically what you can see or hear. It all goes back to synchronization of the network. It all goes back to the codec, referencing PTP and the accuracy of how the offset corrections are made. If there's a lot of traffic and there's a lot of devices on the network, the more belt packs you have on a network, the more traffic there is, maybe the harder it is for the network or the edge devices to correct that PTP offset, to know what that calculation is, to calculate it actively, and to operate as an intercom panel at the same time because somebody keeps pressing it. So again, back to the idea that you have a Luminex network that can only attribute PTP to one VLAN, let's say that's the Bolero VLAN. So now the switches are actively kind of giving the Bolero antennas the answers to the test when you get to the edge of the network. Well, for the panels, that's not the case, because remember, that VLAN is not getting the assistance of the switches to calculate the offset, because the switches are busy doing that for the Bolero VLAN. So now the panels and the cards servicing those panels are kind of on their own. So they have to calculate that offset correction end to end through the whole network without the switch's assistance. So it's a little more difficult, you know, but again, luckily the panels require a little bit less accuracy as opposed to the Bolero VLAN when it comes to PTP offset variance. So, you know, these are the ideas that lead to audio buffer underruns, audio cutting out, momentary loss of synchronization, you know, devices falling offline, such as antennas reporting radio off. All of these things go back to, you know, implementing IGMP, implementing QoS, trying to make the network as predictable as possible. You know, so quick example in context, if you have 211030 4-wire and you play with your packet time, you can have a very short packet time, but it's going to require a ton of bandwidth, okay? And the reason is because you're making the messages shorter. So yeah, the messages, they contain less data than longer messages that get sent less frequently. However, every message that gets sent has a certain overhead. So if you send out 10 messages, they're shorter messages, but there's 10 pieces of overhead. So you're creating artificially bottlenecks in the network. If you have longer packet time, you're sending out information less frequently. You know, maybe you have one package of overhead because you have one message instead of 10. You're creating less traffic artificially on the network, less chance of bottlenecks, less chance of routing issues. The only thing you are doing is you're taxing the buffer in the receive switch a little bit more because the message is bigger. So it has to queue it, and it's a bigger message, and that takes resources, but you know, it's well within the capability of any decent switch. So, you know, you want to try and think about, visualize these things and what's within your control that you can help clean the network up, and what's not in your control, what's deterministic, what's predictable, what's not. Again, PTP-v2, now the network's getting a little bigger. Here's the PTP message, and this is really soup to nuts, kind of in a very simple sense, what's happening. The PTP master will send an announce message. The best master clock algorithm will take those messages and it will determine the best clock for the job. Once that's chosen, that hierarchy has been determined. The one who wins starts to send sync messages. Once the sync messages get to the slave devices sitting on the edge, you know, they're looking for that message from a master. If they don't ever receive one, they themselves will try to be a master. That's why it's so important. You have to make sure that these devices can clearly see the master. The master is in a strategically favorable location on the network. You know, once they see these messages, they ask for delay request messages. So they basically send a message saying, okay, master, how far away are you from me? They will send messages back saying, okay, it took me this long to get a response, therefore you're this far away. And it does that for every device. Now, one more way to clean up traffic in a network, if you have, you know, 30, 40, 50 slave devices, you know, asking this question of a master constantly, which they do, then you're creating an awful lot of traffic in the network, especially when it comes not so much to announce messages and sync messages, because they're just periodic heartbeats. But the delay request response messages get uniquely generated by every edge device and sent to the master. Now, one way to mitigate that traffic and filter out and minimize all of those multicast messages being broadcast to the masses, prevent those multicast messages from being broadcast to the masses. In other words, when the master responds, normally it's responding to every slave device generically. So every request it gets, it's sending the response to every and all slave devices at the same time. So the slave devices are having to, let's say there's 10 edge devices on the network, the slave devices are having to open basically 10 response messages to see which one of them is for them and throw away the other 9. So that's a lot of wasted resources for the edge devices. That's a lot of wasted bandwidth on the network. So what Riedel's done is create a PTP mode on its hardware devices, which is configurable in Artist, called hybrid mode. And hybrid mode essentially takes the delay request portion of PTP and it unicasts it instead of multicasting it. In other words, when each edge device sends that delay request message to the master only responds uniquely back to that one edge device. And it does that for each edge device, so that you're basically, if you have a network with 10 edge devices, you have just minimized your traffic on the network by a factor of 10. So super important, super useful. Remember hybrid mode. And again, Pete, you were asking earlier, where can you see some of the generic, let's say, system health checks on the copper network? You can see it in the IP statistics window in Director under the AES-67 thumb tab. And you could look at a multitude of settings, everything from your delay across the network to a device, the uptime, the outage time, your offset, are you locked as a slave, what master MAC address are you referencing, all the basic information that you would need to know to tell you if that device, in general terms, is working well or not working well. Again, we're looking at the effects of QoS or no QoS, PTP or no PTP. Again, they're just considered necessities on most every network if you're running this type of traffic. Just count on it. Again, looking at the effects like we did a few pages ago of misconfigured QoS, in this case, misconfigured PTP. Similar problems, aliasing of audio leading to the fact that codecs are not tracking sync properly, so they're not playing out properly. Momentary disconnections of devices because they feel that they're outside of the acceptable PTP offset, so they can't appropriately sample sync, so they fall offline, things like that. In terms of network size, we used to go by this kind of mantra of small, medium, large, and I try not to do that so much anymore because, it really tended to pigeonhole people into looking at this and saying, well, I only have one switch or two switches and a couple AES-67 cards and one antenna. You really have to think about not only how many switches you have, where your master is in the context of your network, strategically locating your master because of the distribution of the sync message. But you also have to think about how many belt packs, because besides slave devices, that's fine if you have 10 or 20 slave devices, that's a measurable thing. But really what it comes down to is the number of belt packs in this context of this example, because those are the devices that are creating the payload. Those are the devices that are cumulatively starting to tax the network and possibly create bottlenecks. If you had, 2 or 3 AES-67 matrix cards, you had 2 or 3 antennas and 2 belt packs, well, there's not going to be much traffic, although there are a good amount of slave devices. if you add, 15 or 20 belt packs, that changes things completely, because now you're needing to rely on things like QoS and IGMP to make sure the network traffic is clean, so that you can minimize jitters, so that you can make the delivery of the belt pack audio to the matrix more predictable. So, I would say in my practice, anytime I get above 20 belt packs, 5 antennas, I want to absolutely use PTP, QoS, IGMP, no questions asked. And from there on up to, 100 belt packs, 100 antennas or more. So it's not only the number of switches. And here's another thing to think about. Using PTP compliant switches, because they're more precise, because they understand PTP, and because they are part of the solution instead of part of the problem, compared to non-compliant switches that don't understand PTP, switches known as ordinary clocks. These PTP compliant switches may contribute a PTP offset in the order of 50 nanoseconds. A non-compliant switch, the processing from ingress to egress port of that non-compliant switch is going to be upwards of 250 to 300 nanoseconds. Okay, so if you add 2 or 3 switches, remember that the offset, the PTP offset max is 1 microsecond. It cannot be beyond that. So if you have non-compliant switches, each contributing 250 nanoseconds, you get up to 4 switches, you're done. If you have compliant switches that are contributing only 50 nanoseconds per switch, you can fit a hell of a lot more switches into that network without affecting the PTP process. Never mind the amount of belt packs and the traffic and the jitter that you're adding to that equation. So, it's all about predictability and what can you do. One more thing to look at is our little Dante formula. So here's the problem with Dante, as you all know. It runs a disparate clock. It runs a PTP v1, which is a much different animal than PTP v2. So you cannot operate one on the other, and you can't operate both. In other words, you can't attribute PTP v1 and v2 to a switch. You can't do it. You have to pick one. So herein lies the problem. If you want to run Dante traffic and AES-67 traffic on the network, you have to pick one clock and you have to favor one type of traffic. It's been my experience in experimenting with this for a few years now, that Dante traffic tends to be a little more robust in its ability to survive volatility end-to-end across a network. And because of that, if I'm stuck with this decision, I will typically decide to actively attribute PTP v1 to the switches and cater to the AES-67 traffic, and let the Dante traffic, in essence, fend for itself end to end across the network. Okay, so now what you're doing is you're saying on one VLAN, I have AES-67 traffic. On this VLAN, I'm actively attributing PTP v2 to this VLAN. So I, as the switch, am aware of the grandmaster sending PTP v2 into the AES-67 VLAN, and I am assisting with the offset error correction values, and I'm sending those values to each and every edge device to tell them, what the answer to the test is and how to recalculate to get back to time equals 0. Meanwhile, on VLAN 1, I have Dante traffic, and the switch is not participating. So you're telling the Dante edge devices to kind of, figure it out on your own. But the good thing is, on most networks that aren't that big, that don't have that many switch hops, the Dante edge devices are able to calculate that offset on their own without the assistance of the switches, and do it fairly well. So problem solved. Yes and no. You still have Dante traffic that outside of the network is referencing to its own clock, which is PTP v1. Now, the problem is that not every switch will allow v1 traffic to pass through it if you're referencing that switch to v2. So in many cases, if you're trying to send it through a common set of trunks or ISLs between switches, there is the chance, depending on the switch manufacturer and how they write their trunk filtering rules, that the v1 traffic will be blocked because the switches are attributed to v2, and they're going to say, what's this? I don't know what this is. I'm not letting you pass. On some switches, it doesn't care and it will let it pass. However, the moral of the story is if it doesn't allow it to pass, you simply define a discrete and separate set of trunks to send the Dante traffic through. Problem solved. And you define those trunks separately and uniquely based on v1 filtering instead of v2 filtering, so it doesn't get blocked. So problem number 2 out of the way. Problem number 3, as this page refers to or alludes to slightly, is that the DSCP tags, the QoS policies for Dante and for AES-67 conflict with one another. Again, the AES-67 clock traffic sits at a value of 46. That happens to be the value of Dante's media traffic. So in some manufacturers and in some edge devices and in some software management of those edge devices, they allow you to reconfigure the DSCP tag so that they don't conflict. The problem on a large scale is that you can't have them conflicting because in AES-67 world, 46 is media traffic. In Dante world, 46 in Dante world is media traffic, 46 in AES-67 world is clock traffic. So that's a problem. It's always going to prioritize the clock traffic because of how it does the queuing generically. So what you need to do is kind of do what this picture tells us to do. You're taking clock traffic of Dante and clock traffic of AES-67. And although they're different QoS values, you're attributing them to a common class of traffic and a common transmit queue that has a higher priority. So you're saying, take clock at Dante 56 and take clock at AES-67 value 46. And even though 56 is higher than 46, they're both clock traffic. I'm going to send them to the same class, and I'm going to send that class to a common transmit queue. And you're going to do the same thing with media traffic. You're not changing the definition of QoS or COS. You're simply taking those generic definitions for each of their independent QoSs and sending them to the right and common transmit queue. So clock traffic for each will get sent with priority. Media traffic for each will get sent with priority and a slightly lower priority than the clock. Above and beyond that, in switches that allow it, such as the Nexus 9Ks, such as the Arista 7000s, you have the ability to define on a per port basis, for the most part, QoS provisioning. So you can kind of do that mapping on a port provisioning level as opposed to a deeper level like this, where you are remapping in the transmit queue, deep inside the switch. So it really just depends on where that switch management for that manufacturer exposes this implementation to you, whether it's at the port provisioning level or whether it's deeper in the switch management, at the bare bones transmit queue level. But the bottom line is it can be dealt with, and you can absolutely pass both types of traffic through a common network if you configure it correctly.
David, John Arenas wants to know, can you explain which devices should be in hybrid mode?
Yeah, typically any device that can be, and typically that's any network edge device hardware that's going to be, requesting messaging from the master. So that could be a card, that could be an antenna. You know, typically right now it's available in everything but the Bolero antenna, I believe. And it actually, maybe off the top of my head, I'm going to have to look at that menu. But the idea is ultimately to have that menu available on every hardware edge device, so that you can clean up the network accordingly. And you're going to find that in the
Can you
PTP
show where that
property.
you have an artist file open? You can show where that's set.
I probably could start one up. Actually, I'm on a different network right now, so I can't. But it is in the properties menu for example, the AES67 card. If you go to the AES67 thumb tab, you're going to see a setting for PTP. You're going to see a setting for your PTP priority value, and you're also going to have a setting for master slave and a setting for hybrid mode or normal PTP mode. So that's again going to be in your properties menu in the AES67 thumb tab. And that's about the end of my story for the moment. Any questions? It's kind of a lot of information.
Ryan points out that it's important to know that any CLI command is a live state change and not a change that would survive a reboot.
In most cases, but I can't say that definitively for every switch.
Yeah. And then a couple of people, Dave Carr and Caleb, mentioned that Luminex has their software called Areneo, A-R-A-N-E-O, that can show you a full system overview of all the Luminex switches in a network with configuration and data flows shown. That's
Okay, cool.
Luminex Areneo software.
Yeah, I'll have to check that out. Thank you for that.
Cool.
Yeah, Luminet is useful as well, but that one sounds that sounds pretty cool too. I'm gonna check that out.
And now, just to summarize, I want to put up on the screen a list I've been sort of trying to follow along with, which shows important settings for a Bolero system.
Mm-hmm.
So this list here, let me know if I've done something wrong in there and what you would add to it.
Well, I mean, you know, there's a lot I would add to it. You know, it's really been 2 hours of content.
I only allow 10 recommendations maximum from the manufacturer. So you have 5 more.
I mean, I would say also in item 1 that you don't want to pigeonhole yourself into just saying that the idea is that if you have more than 35 slave edge devices, they could coincidentally, if the numbers worked out right and you had the right quantity and portions of panels versus Bolero, you could solve the problem by splitting them into different VLANs. You know, the problem is you can't really take Bolero and split it into multiple VLANs unless you're using an external grandmaster, and unless you know, it's an even playing field as far as
well, if you're using
VLAN.
Luminex with all of them, let's say if they put them all on the same VLAN.
Yeah, you'd have to do that.
Right.
But you know, the bigger resounding point above and beyond the 35 devices, other than splitting into, you know, segregating into different groups, is the idea that if you get above 35 and the idea is that you really want to stay within one VLAN, then it's time to go to an external grandmaster.
Okay. And by external grandmaster, what do you mean?
Something other than a AES67108 card or a Bolero antenna. assuming control of the network as the master.
And can you recommend a typical device?
Yeah, the Tektronix, Meinberg, Evertz, all the usual players. But those three we do have quite a bit of experience with in testing.
Do you have any recommended ones on your website?
I don't know if we officially endorse them,
Right.
publicly on the website, but I can tell you that the SPGA 8000, the Meinberg, the Evertz, those are all pretty standard fare.
Okay. And then do I have the numbers right for those possible PTP settings? If you wanted to set them?
Yeah, and again, those are arbitrary. The whole point
Yep.
being is that
Just the order.
120 is going to be your lowest value you can go to. And yeah, the idea here is the order and the succession.
So 120 is the highest priority.
Yeah, that's pretty much the best you can do.
Right.
And of course that scenario wouldn't change if you had, if you had the master Bolero at 123 and the other Boleros at 124 and the AES S67 cards at 125. You're not changing that scenario.
It doesn't make any difference as long as they're in order. I could do 120, 121, 122.
Yeah. So in other words, the point I want to stress is that there's no added priority based on the value itself. There's
Right.
only priority based on one number being lower than the next.
Right. Anything else? You have 5 more recommendations allowed.
Try to limit switch hops to 3. Again, you can go to 4 with non-compliant switches, but it's really less about the switches, the number of switch hops at that point,
Right.
more about the volume of traffic and the number of edge devices on it. It's a very, like, I wouldn't want to make that blanket statement that number 4 is listing. Number 5, QoS and IGMP. Certainly great. 6, use PTP compliant switches.
Well, just remember that because my keyboard is frozen. I can't type in.
Okay. Well, I mean, honestly, the list is the past 2 hours anyway. So there you go.
Take this video and put it in your pocket.
Right.
Cool. Well, it's been really a terrific presentation you've done.
Yeah, a lot of information, but hopefully, for the folks who have used it for quite some time now, this sheds a little bit of light on the bigger picture in terms of concept and design. And for a number of you, I know this is old hat, so thanks for hanging in there.
Yeah, I see, Pete, that your list created as many questions as it answered, which is exactly the purpose of our webinar here.
Hey, if I can break it, I'll do it. I'll do it.
Well, and you pretty much break the internet every day. We're on the air together, so that's okay. But yeah, I think there are some good questions here that we should probably collect and send over to you, David. There are just 2 or 3 we want to. Mark and Henry and John. Saw your questions in here. We're going to get those over to David so he can just crank out a few answers on those. But want to be mindful of your time, David. Thank you very much for joining us on this one. This is one of those topics that just it generates, again, as many questions as it answers. And as we get in front of this gear, I think that'll also help when we get back in the marketplace, obviously. What do we got? Go ahead.
These questions will be posted as a download with the video. And several people have asked for your deck, but obviously it's a lot of different things. Maybe some of it we can share with them, but certainly.
Yeah, sure. I can upload a few of them. for sure.
Sure. Great. Perfect.
Yeah, we'll kind of pull that together. So thanks again, David, for that, especially just being all over the map on this one. Thanks a lot for pulling it together. Wednesday is sound design for sports audio. Carl Malone from NBC Sports and Olympics for them. And then Dave Grundtvig from last week on the A1 panel is going to be coming back, and we're going to be talking all about miking for sports, touching on immersive audio, Dolby Atmos, trying to create a soundscape that is compelling and interesting to viewers. Even the simplest sports, why some things he and I were actually talking today, and it's like, well, what about diving? How hard could it be to mic diving? But actually there's some really cool stuff, right? You know, and we'll do our best. Again, that's going to be one of those topics that just more questions than answers. And then Fiber Guy on Friday, all about maintenance, field maintenance of fiber and that importance. So you ask, we're finding. I've got my notes going, and Pete's obviously taking copious notes. And thanks for that. And everybody have a great week. Enjoy your evening. And we will be back together on Wednesday. Keep an eye on the website, right?
Definitely.
Recordings.
And the videos are all on our website as well as YouTube. And for the time being, we will continue to do that. They tend to get up on about the same time, about 24 hours after the show. So if you can't find it on one, look on the other.
Yeah, YouTube's a great place to go. We don't require any registration there. You can just go pull it down. So when you're out in the field and you need to look up what David's answers were today, you can be out on show site, hit YouTube, go find this video, pull it up right on show site. It's brilliant.
The list of questions has a time on it into the video. So if you want to know about a particular question, just look at the time and scrub to where that time is, and then you have all the answers in the world.
Excellent.
One at
All
a time.
right. So that'll do it. Have a
Yep.
great evening.
Thanks a lot,
So
Dave.
long,
Bye.
folks.
Thanks, David.
Dave.
Thanks, everybody.
All right.
Have a great night.
You too.